All right, let's take a look at some of the problems that are going to be on the final exam. So again, these problems on this are very, very similar to what you're going to see. So this first one, we need to find the inverse of a function. And generally that means we're looking for a function that has the opposite calculations in the reverse order. So if you look at this problem, the x is being multiplied by 2, and there's a subtract 3. So that means our answer is going to have like the opposite of those. Like it's going to have a divide by 2, and it's going to have a plus 3. So with that in mind, I can see that those two choices are out because they don't have a plus, like this one's got minus 3 instead of plus 3, and this one's got times 2 instead of divide by 2. So those are both out. If you look at these two, these both have the plus 3 and they both have the divide by 2, but they are a little bit different. So the best way I can explain this is when you look at the original problem, 2x minus 3, the first thing that happens to the x value is that it's multiplied by 2. The second thing that happens is the minus 3 part. So to do an inverse, you do the the opposite calculations in the reverse order. So it means instead of minusing 3, the first thing that has to happen is a plus 3, followed by the opposite of multiplying by 2 would be a divide by 2. And so with that in mind, I take an x, the first thing I do is add 3, and then I divide the whole thing by 2, just because the calculation of adding 3 has to complete itself. And that's the difference there. But at least we were able, just from basic understanding of inverse, to eliminate half the answer choices and increase the probability of guessing correctly. Number 2, we need to be able to solve some equations. This one is a radical equation, so I rewrite it. So we have the square root of 9q minus 8 equals 8. One of the things we learned is that the first thing to deal with square roots is to do the opposite of square rooting, which is to square both sides. And that cancels out your square root sign, and that equals 64. Now I would do a little plus 8 to both sides, and that gives me 9q equals, let's see, 64 plus 8, 72. And then if I divide both sides by 9, I get q is equal to 8. And A is the answer. All right, we move on. Working with rational functions, subtracting, adding, multiplying, that stuff's going to be on there. That's from our most recent test. This one, we pretty much just need to work this problem out. Let me recopy it. 2x minus 1 over x squared minus x minus 12 minus 1 over x minus 4. So the first thing I'm noticing is that the bottom left here actually needs to be factored. So I'm looking at this little bit right here, realizing that's a 3-term polynomial, and it can factor into one of these things. What two numbers multiply to make 12, negative 12, that add up to negative 1? Well, that's negative 4 and positive 3. All right. So from there we can kind of see, as far as our two fractions go, this one has the x minus 4 and so does this one, but this one also has this little x plus 3. So we've talked about how we need to come up with a common denominator. Well, the common denominator for these two fractions then would be the more complicated of the two. So that's what our common denominator is going to be. And the top of this first fraction, I don't have to mess with that because it already has the common denominator. But the second one, that one I'm going to need to basically multiply it by an x plus 3 to give it the common denominator. But what you do to the bottom, you have to do to the top. And so that leaves me with kind of this, I guess, distribution situation, 1 times x and 1 times 3. That just gives me x plus 3. So as far as the final answer goes, it's going to be one fraction with the common denominator. And if you look at this, I've got kind of like terms. 2x minus x would be 1x. And furthermore, negative 1 minus 3. Negative 1 minus 3 would be negative 4, minus 4. And what's interesting about that then, just to make this problem one more step complicated, you can now see that I've got an x minus 4 and an x minus 4 on top and bottom, and those cancel out. That's not always going to happen, it just happens here, and that leaves us with a final answer of 1 over x plus 3. The 1 has to be on top because something has to be up there, and so C is our best answer. So A and B were pretty tempting if you understood common denominators, but it turns out C is the better answer there. What you really want to avoid doing with these subtraction problems is thinking that you can just somehow just go straight across the top and, 2x minus 1 minus 1, like those just don't really like cancel out or anything. Moving on. Exponential functions, exponential growth and decay was something that we've discussed. Let's see, over the past several months, the water level of a lake has been decreasing by 3% each week. If the highest water level was 536 feet, what was the water level at the end of 6 weeks? The basic setup for this problem is understanding that it's exponential, which means it should fit the format of like a starting value, I'm writing A, times some sort of growth rate, I'm just going to put B for that, to the x power. So with that in mind, A is the starting value, which in this case the water level was 536 feet. So I'd put that as my A value. The growth rate is a little bit complicated. We're decreasing by 3%, which actually means like 100% minus 3% is 97%. And you actually express that as a decimal. And then it's normally to the x power, but in this case it says it's after 6 weeks. So we put a 6 up there as the exponent, and we pull out a calculator and solve 536 times 0.97 to the 6th power, and I'm getting an answer of 446 and some decimals feet. So 446.5 feet or thereabouts. Exponential growth, very similar to the last problem. Suppose you deposit $1,000 in a savings account that pays interest at an annual rate of 3%. If no other money is added or withdrawn from the account, how much would you have in the account after 10 years? Well, this time our money is growing, so it's going to be, we start with 1,000. The growth rate is going to be 100%, because that's what you have, like you keep whatever you've got, plus you're adding 3% more. And with that in mind, that's 103%. Which would be represented by the decimal 1.03. And then again, it'd be to the x power, which in this case would be 10 years. So there's our formula. Calculator says after 10 years, we would have $1,343 and about 92 cents. Not a lot of money, not the best investment somebody's ever made, but there you go. All right, we have to graph or find which one of these functions is going to make that equation up there, and goodness, those equations all look very, very similar. So honestly, what I would recommend on this problem is to probably grab a graphing calculator and type in each one of these into y equals, and then see which one matches this graph. That being said, we can do a little bit of elimination based off of some things we've done in class. For example, we've actually learned that this number in front is the starting value. So 4, 3, 4, 3, they're only giving us two choices. And it turns out that the starting value would always be this dot where it touches the y-axis, the y-intercept. So they're actually, by putting this point on the graph, they're trying to tell you that the front number should be a 3. So with that in mind, I can basically cross off those two choices. But that still leaves me with 3 to figure out. At this point, you just kind of have to play around with the equations here. I am noticing they do give us one other point up there. That's the number 1, 12. So, again, I would probably use a calculator here, but since I don't have one on the screen, basically I would take that point, 1, 12, understanding that that's an x value, and this is like a y value. So if I take each one of these equations, so if I say take this one, 3 times 4 to the, and it says negative x power, so that'd be like to the negative 1 power. That does not actually give me 12 if you type that in a calculator. That actually gives me the fraction 3/4, 0.75. So that doesn't work. This one, that 3 times 4 to the 1 power, well, that's 3 times 4, which is totally 12. So I'm feeling pretty good about that one. Just to prove a point, this one down here, 3 times 3 to the 1 power would give you 9. So it's definitely this one. So if you can sort of use the graph and identify points and numbers and x values and stuff, eventually you can get those straightened out. It just takes a little hard work. What is the horizontal asymptote of that function? Well, according to notes and stuff that we've taken in the past, this number right here is the a value. It controls like whether it's a vertical stretch or compression. This number right there, that 5, is the h value, and that causes the graph to shift left and right. And this number back here is the k value, which causes the graph to go up and down, which is actually what we're talking about, because a horizontal asymptote is sort of a up and down boundary. Anyway, what we've learned in our notes is that it's always that k number back there. So this is the one we want. That's our horizontal asymptote value. That's really all I can say about that. One way, if that didn't make any sense, if you just type this into the calculator, into y equals, and take a look at it, you're going to see, I'm guessing, a graph that's going to kind of go like, gosh, what's that going to look like? It's going to kind of go like this. And the point is, it's kind of like there's this flat line thing going on at 4, which is caused by that 4 back there. All right, continuing on, this question is talking about the restricted values of rational functions. Restricted values are values that cause the denominator to be 0, because that then you're dividing by 0, and that's against the mathematical law. So I guess as I'm looking at this, one thing that we tried to watch for is, does anything cancel out? In this case, nothing reduces or cancels out. All I really need to do is look at the bottom. So what I'm really looking at is the denominator, and what I'm thinking about is, what number plus 9 would give me 0? Because that's going to be an issue. And also, what number plus 7 is going to equal 0? Because that's going to be an issue too. And if you solve those or think about it, that means that x is equal to negative 9 is an issue, and x equals negative 7 is an issue, and that's the answer for C. Moving on, we are multiplying some rational functions. What's interesting about these problems is we really don't do a whole lot of multiplication. We actually mostly do a lot of simplification. So what I'm going to do is, let's see, I can't do much with that. Can't do much with that. I can factor the top right part. That's going to factor to be two numbers that multiply to make negative 15 add up to 2. That would be positive 5 and negative 3. The bottom also factors. I'm looking for two numbers that multiply to make negative 2 that add up to negative 1. And those numbers are negative 2 and positive 1. So hopefully factoring is not an issue there. But Now at this point we can just cancel some stuff. We have an x plus 1, see you later. We have a couple x minus 3's, say goodbye to those. And we're essentially left with our final answer, x plus 5 over x minus 2. All these answers looking very similar, but there you go. That is a divide problem, very, very similar to the last problem. It's just that, so we turn the division into multiply, and we flip this fraction. So the second fraction gets flipped like that, and then I still have to factor all these guys over here. So just working real quick. That's how those factor out, and then you can cancel some stuff. So see you later, goodbye. There's our final answer right there, x plus 3 over x minus 2.